one more thing. Save it. Okay, good. So when I was 10 years old, I was in 5th grade, Mr. Cunningham's class. Now, Mr. Cunningham saw me looking at lots of books about the solar system. I told him that I wanted to be an astronomer and I wanted to be an astronaut. And he said, Kramer, that's cool, but you better get your facts straight. And I said, this is the way he spoke to me. And I said, Mr. Cunningham, what do you mean I have to get my facts straight? And he goes, well, Kramer, the picture you're looking at has no basis in reality. In fact, he probably would have said that this model of the solar system was more accurate than the one you're looking at on your screen. Do you guys see it on your screen?
Yeah, wait.
Yes.
Oh, yeah, because, oh.
Now, guys, I said to him, I said, well, tell me about reality. And then he did. He showed me about all the different diameters of the planets and the sun. And I couldn't believe it. I want everybody right now to take page 1. Notice that on the bottom, I actually gave you a centimeter ruler. So it's millimeters, centimeters. If you don't have a ruler, you can use it. Put it to the left or the right of your workspace, please. Put it to the left or right of your workspace. And here is what we're going to do. We are going to take a journey together through the solar system, but we are going to be scientific about this process. And here's what we're going to do. I've never done this before, so I'm going to try it for the first time. I worked this week to try to figure out how to set up an overhead camera. See if this works. And I'm hoping that you're going to see my hand in a second.
Okay.
And do you see my hand?
Yeah.
Yeah.
Okay, good, 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 good. Now, what we're going to do is we're going to take our Play-Doh, and I want you guys to look at this, and I want you to think about it as a percentage of all the mass in the solar system of the planets. All the mass of the solar system of the planets. Olivia, can you please change your screen from the upside down flashing screen to no flashing and no upside down, please?
For some reason, it just turned like that, and I don't know how to turn it off. I think my camera like disconnected like halfway or something.
Yeah, go to your, because it's kind of flashing, you may want to turn off your
Go to video
video.
settings and
I'm going
press
to say
rotate,
stop video for just a
whatever it
minute,
is.
and why don't you figure out, and then come on back. So this, guys, is 100%. This is 100% of the mass of the solar system.
Wait, let's quickly writing that.
My very excellent mother just
Served us noodles.
served us 9 pizzas.
Nacho. Oh, yeah.
9 pizzas. So Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto. And oh, by the way, let's have a maturity conversation. I have almost never had a conversation with somebody about the planet between Saturn and Neptune and had them not giggle, okay? Now, I want to give you accuracy on this. It is actually accepted in our society to say Uranus, but it is not that at all. If we're going to focus on scientific accuracy, I want you to think of the Latin. Uranus, like Uranus was named, it's a Latin word, okay? And Uranus is just how it looks, but that is not what it is. So Uranus, everybody say Uranus, please, go.
Uranus.
Uranus, very, very good. Okay, good. Now, let's get started. What we're gonna do is create right now a cylinder. If you create a cylinder, the top of the cylinder, of course, will be a circle as well as the bottom, but the side view will look like a rectangle. So I want you to create as good of a cylinder as you can. What I like to do is kind of just squeeze it, keep squeezing it, kind of like to what looks like a potato. And then once it starts to look like a potato, I smush one of the ends and it gives me a nice little circle. Smush the other end.
Oh, take that.
And then start rolling it again. Now it kind of looks like salami, I guess. And although I don't eat salami anymore, and that's what you should have. Now, what I would like you guys to do is measure it in millimeters. So take your measuring device or the piece of paper that I gave you on page 1. Mine is 120 millimeters. It's 12 centimeters.
This is 12.
Does anybody have a good number they can share with me? Go for it, Ben.
Mine is 75 centimeters.
Okay, you mean 75
Millimeters.
millimeters, because 75 centimeters, let me just show you a second, please. Ben, this is a meter stick. This is 100 centimeters, and right here is 75. So this is 75 centimeters or 750 millimeters, okay? And very, very good. Will?
Mine is 80 millimeters.
Okay, I dig it. I dig it. I kind of like the 80. Hannah, what about yours?
Mine's 60 millimeters.
60. What about yours, Seth?
95.
Adalia? Adalia, you're muted, honey.
110 millimeters.
Cool. And Regan?
Mine is also 110 millimeters.
Oh, cool. Now, I happen to like Regan's the best, and I'll tell you why. I'm into 110. I wish mine were 110 and not 120, because I like counting by 11s. Really like counting by 11s. But I also like counting by 12s. Please make sure you have a plastic knife. The only one who may not is Hannah, because she's cutting up an apple. Hannah, be careful, please. Your hands are very special. Now, I want you guys to please separate this into 10 equal pieces. Do not cut them though, just mark them. So I'm gonna mark every 12 millimeters. So my first one is 12, 24, 36, 48, 60. I wish I were doing Regan's right now. 72, 84, 96, 108, and 120. And I'm liking my tenths right now. Can anybody show me theirs? Oh, Zarak? Zarak, are you there, buddy? I don't see you. Yeah, you have a question, bud? Oh, your hand was raised. Okay, David, let me see yours. Oh, nice, nice. And Luca, let me see yours. Oh, whoa. Oh, Adalia's is so cool. Guys, check out what Adalia did. Adalia, she separated it into fifths and then cut it in half. Now, Adalia, did you do fifths first or halves first? Tell me which one.
Fifth.
Oh, such a great way to do it. Nick, let me see yours. Oh, very, very nice. Okay, guys, I want you guys to cut down, not in the halfway. I want you to go one over so you have 60% and 40%. So everybody cut 60% and 40%. Now, I want you to pick up one of the planets right now. And you're going to be picking up one of my favorite planets of all time, which is difficult to pick up because it's made of gas. And it is the planet Jupiter. Jupiter is 60% of the mass of the planets in our solar system. So everybody make a nice sphere. Remember, there's no such thing as a perfect sphere. It doesn't exist. It's a theoretical ball. It's a theoretical set of an infinite number of points that are equidistant from the center. That's the definition of a sphere.
I watched a YouTube video and it was about like some people spending hours and hours of time to make a sphere perfectly round.
Well, there is actually a Guinness Book of World Record for a sphere that's made out of metal, and it was machined by a company that I think makes ball bearings. So it's amazing. I didn't even realize that that existed. In any event, guys, please take Jupiter and put it down next to Jupiter on the picture on your page 1.
Wait, Mr. Kramer, how do they measure the roundness?
Jupiter is huge.
Well, what they do, I want you to watch what I'm doing. I am touching the north and south pole of my sphere right now. Now I am touching another north and south pole. So what they do, Ethan, is they measure the diameter. It's almost like measuring an infinite number of diameters. And if you measure an infinite number of diameters and they're all exactly the same to some sort of factor, maybe 10 to the negative 5th power, you know that you're getting really close to as perfect a sphere as you can. Okay, put Jupiter down, guys. Pick up the rest of our solar system. Now, I want you guys, I love it, Hannah. I love the apple. Now, I want you guys to please cut off 1/10 of the whole mass, or 1/4 of our 40%. So 1/10 of the whole, or 1/4 of 2/5. So here we are. This represents 1/4 of 2/5, which, as you can see, is going to be 1/5 of the entire mass of the solar system. Okay, and
1/10.
I'm sorry, 1/10. My bad. 1/10 or 10%. This is 1/10 or 10%. Now, this is 3/10 or 30%. And I would like you to roll it up, but it is not yet a planet. This is not yet a planet, but it's pretty close. So 30% of the mass of the solar system, planets, is pretty close to Saturn. So please put Saturn next to Jupiter. And I want you to focus on this remaining 10%. Now, what I want you to do now is I want you to make another cylinder. I want you to make another cylinder, and I'm actually going to, and this kind of looks like a Tootsie Roll right now. I'm gonna mash the sides to make it look more rectangular.
How are we supposed to know how big of a cylinder?
It does not matter. It could be, mine is is 105 millimeters. How much is yours? Hannah, how much is yours?
105.
105. David?
80 millimeters.
80. Adalia?
120.
All
125
right.
millimeter.
Guys, I want you now to do the same thing. Mine is 100. Actually, you know what I'm going to do? I'm going to make my life easy. I'm going to squish it a little bit and make it 10 centimeters.
But then
I-
that's to scale.
I was not successful. Say again, please.
Well, you would be closer to scale if it was.
Yep, that's pretty good. So guys, I'm going to actually make 10. I'm going to make tenths right now.
Oh, this is so much harder than kneading dough.
Now, yours should look like this, and you are looking at 10% of the mass of the solar system. And what I want you to do is I want you to cut off 10% of 10%, which is what percent?
1%.
You are looking at 1% of the mass of the solar system. Then I want you to cut off 2/10. That's 2%. Another 2/10, which is 2%. And then leave these 5/10 together. So we've got 2% of the total mass plus 2% plus 1% plus 5%. And that represents the last 10%. Now, pick up this 5%, please. And we're going to add it to my favorite planet, and that is Saturn. Before we add it to Saturn, we're going to do a little exercise. I want you to measure the diameter, if you can, of your sphere. My sphere has a diameter of 5 centimeters. And what I want you to notice is that in order for you to make the ring of Saturn, which is what I'm going to do right now, we're going to have to multiply the diameter, say it on 3, by what number? On 3. 1, 2, 3, go.
Pi.
3.
3.
Well, in the Old Testament of the Bible, it actually says that the number pi is 3, the ratio of the circumference to the diameter of a circle. And that's about 5,000 years ago. Now, the Egyptians did a little bit better. They were at 3 1/3. And it wasn't until the Babylonians came by that they realized that pi was an irrational number very close to what fraction? Andreas?
22/7.
But give it to me as a mixed number. So
Oh, okay, 3 1/7.
yeah, so guys, I'm actually going to try to create something that is a little more than 3 times my 5 centimeters. So I'm going to measure it right now, and guess what?
Oh, 4 times.
I went way too much.
Yeah.
I went way too much. So what I'm actually going to do is I'm going to cut it off at what I think is pi. And I'm going to take this and I'm going to kind of stretch it and try to make it uniform. And that's pretty good. And now let's see how good I did. I did okay. I did a little bit better than the Egyptians, maybe not as good as the Babylonians. And what I like to do is I like to pinch. I like to pinch the ring into Saturn. Now, you guys might find this interesting, but we used to think we used to think that Saturn was bigger than Jupiter. Does anybody know why we used to think that? Can anybody share, please?
Because of the rings.
Because of the rings. The rings of Saturn are actually a larger diameter than the planet of Jupiter. Pretty amazing, guys. By the way, we're not done with Saturn, but put it down for a minute. Put it down for a minute. Now I want you to pick up these two sister planets. These two sister planets are so close in size. Can anybody tell me what they are? I'm going to go with, let's see. Who's going to raise their hand electronically? Okay, we're going to go with, let's see, Lila.
Is it Neptune?
Go ahead, honey. I can't hear you.
Is it Neptune and Mercury?
Ah, it is not Neptune and Mercury, but great thinking. I'm gonna go with I think it's Alex. It says Melissa, but I'm gonna go with Alex.
Is it Earth and Venus?
Earth and Venus are called sister planets, and these are not them. These are not them. Seth, what do you think?
Uranus and Neptune.
And they are. Uranus and Neptune, guys, are 40 times bigger than Earth. In volume, Neptune and Uranus are 40 times bigger than the mass of planet Earth. They each make up 2% of the total in our solar system. Please make your spheres, put them at Uranus and Neptune next to Saturn. And guys, we are now looking at 1% of the mass of the solar system. Now, the really weird thing is I already told you that we're not done with Saturn. So this includes part of Saturn. It includes all of Mercury, Venus, Earth, Mars, and Pluto. Can you please make a cylinder? By the way, this is a terrible cylinder because it is not uniform. So I want you to make either a rectangular prism, would also be fine. I really would be interested to know how Hannah is pulling this off with an apple. I've actually never had a student do that. I think it's very brave. And I'm kind of looking forward, Hannah, to you to send me a picture. Before the apple rots, I want you to send me a really good picture on your solar system. And I want you guys to all send me pictures of what you come up with. Oh, David, looking good, looking good. Okay, now, I want you guys now to please cut off a 10th. So just kind of eyeball it or use your ruler and cut off 1/10. So we have just gone from 1% to 1/10 of 1% and 9/10 of 1%. Who can tell me what that is as a fraction? 1/10 of 1%. Who can do that? Luca, you have your hand up. Ethan?
1,000.
Ooh, I like it. 1/1000. Absolutely beautiful. And therefore, the 9/10 of 1% is what, guys? Come on, you can say it out loud.
9,000.
1,000.
9,000.
9,000.
So, Saturn is 35.9% of the mass of the solar system planets. Pick up your 0.9% and please add it to Saturn. I have nothing interesting for you except maybe you could, like, I don't know, quickly turn it into like an S. If you turned it into an S, For Saturn, maybe that would be interesting. S is also for snake. And then you could like put the S right on Saturn. Although I've actually seen Saturn with a telescope, and it does not have a big S on it like Superman. So there we have Saturn, 35.9% of the mass of the solar system. Here is Jupiter. And as you can see, I've made the planet rings wider than the diameter of Jupiter. So really enjoying that. And now I am left with 1/1000th of the entire mass of the solar system. And what I want you to do, well, of course, I want you to make a cylinder out of it. And
this is getting kind of hard.
Oh, you haven't seen anything yet. This is not even the tricky part. Okay? So don't get crazy with me, because this is not even the tricky part. We are still at 1/10 of 1% or 1/1000th, and you are about to cut this in half.
You kidding me?
I also have some caution. This is a cautionary issue. When you pick up 1/2, I want you to take the most beautiful care of this, because you are now holding your own planet. This is a proportional model,
How is this supposed to?
1/40th of Neptune, 1/1200th of Jupiter, 1/718th of Saturn. This is the planet in which you live, guys. This is Earth. So be careful. Do not drop it. Wait, I thought, Hannah, did you drop it? No. Okay, don't drop Earth, because if you drop it, you know what happens to us, okay? Walker, be careful. Be careful with your planet, okay? Please put it on planet Earth right now.
I rolled Jupiter over it.
Oh, you know,
If Jupiter accidentally rolls, it's going right over us.
and you know, guys, I was always thinking that Jupiter would be really light, and I don't really know much about it, but gases can be actually very heavy. So Jupiter, even though it is gas, is still a very heavy planet. Now,
Yeah.
we are now looking, guys, at what percent. Who's going to give me the percent and the fraction? Raise your hand electronically, please, so I know what you got for me. Nobody's raising their hand. Luca, go for it.
5/1000.
Well, that would be 5 times this, 5 times Earth. And remember, Earth plus that was 1/1000. Now we're doing half. And watch this, Luca. Half of 1/1000, which is 1 what, guys? Come on, multiply across.
1/2000.
Or 1/5 of 1%. You guys see it? And so we now have 1/5 of 1% left, or 1/2000th. Put Earth back where it belongs. I'm sort of giving my own instruction. And then, guys, I want you to take that and I want you to roll it into a nice little cylinder.
Already done. Knew you were going to say that.
Now, I wonder how you knew. Now, this guy here, I'm going to actually measure the number of millimeters, because it looks to be more than a centimeter. Actually, what am I doing with the standard system?
I have 15.
Oh, wait, who said they have 15?
1 millimeter.
I have 15.
1 millimeter thing.
I also have.
I
15.
have
I also have
13.
15.
All right,
I
guys,
also
you
have
I
ready?
have 15 millimeters. You guys just have 15.
Pick up your scalpel,
I have around 12.
because remember,
boy.
you are astronomical surgeons. Today, you are astronomical surgeons. So be careful. Can you please cut off 1/10?
7.
So I'm going to cut off 1.5 millimeters.
Wait, what?
I just cut off 1/10. Now, everyone, 1/10 of 1/2000. Who can tell me what it is? On 3. 1, 2, 3.
120,000.
Which is what percent?
A lot.
150th.
150th.
So it is 1/50th of 1%.
Do we have to roll this into a cylinder?
Well, hold on a second. Remember you guys were saying, somebody said that Venus and Earth were sister planets, and they are. Venus is actually 90%. Venus is actually 90% of the volume of planet Earth. I do not know why they call it sister planet. I'll tell you why I'm upset about it.
Oh, I bet we're rolling.
I
the
am
next one
upset
into a
about
cylinder
this
too.
because we could never set foot on Venus. Venus is so hot because the ozone layer is so thick that when the sun heats up Venus, the ozone layer traps all of the heat. Now, you know that our planet is warming, correct? Now, we should never get like Venus, but that's the reason why we want to protect our planet, because Venus is uninhabitable. You can melt lead on the surface of Venus. So please, roll Venus into a sphere. She is 90% of planet Earth. Who can tell me what percent Earth is of Venus? Who can tell me that?
110?
No, it's not 110, but think about it. Don't think out loud. Raise your hand electronically. If Venus is 90% of Earth, then Earth is what percent of Venus? Andreas. Andreas, you are muted, my friend. You are muted.
The Earth is 111.111% of.
That's right, guys, because Earth is 1/9 bigger than Venus, so 1/9 is 11.1 repeating percent. And therefore, Earth is 111.1 repeating percent of Venus. So be careful with that 110%. That's kind of a mistake that I've made many times. Now, please take this 1/50th of 1%. And what are you going to do with it?
Roll it into a cylinder.
Of course. Now, I want you to try to make this into a cylinder that is 10 centimeters long.
Oh, that's going to be tough.
Oh,
Centimeters?
that was a joke. I'm kidding. I will tell you, though, that my hand, after
Mine is 10 millimeters.
of this, I am actually going to clean my
Yeah.
hands.
My hands are like,
millimeters.
hey.
Now, guys, this 1/20,000th of the solar system mass represents 3 remaining planets.
This
Oh
is
my God.
ridiculous.
And guys, I'm having trouble, so I'm going to use my tool to smash it a little bit. And I want you, and it actually looks like a little mice dropping. I'm going to cut off 1/10. Please join me in cutting off 1/10.
It's a very.
Now, of course, we know that we have just cut off
Pluto.
1/200,000th,
Oh my gosh.
or 1/500th of 1% of the solar system. And can anybody tell me what fraction is this little piece right here?
A lot.
which is 9 times bigger. This is 9 times bigger. Everybody say it out loud. Go.
9
That's it.
200.
It's 9 of the. And how many? What percent?
9 500.
9/500ths of 1%. Now, you have just, by the way, this is very important. How many of you got to see the launch of SpaceX on Saturday?
I did.
It was awesome.
Now, guys,
Named a dog after it.
I have to say that Elon Musk is one of the craziest, most brilliant inventors this world has ever seen. He invented the Tesla car as well as SpaceX. He wants us to live here.
Mars?
He wants us to live on Mars. Mars,
Elon Musk bought Tesla.
he almost bought Mars. No, I'm kidding. So, guys, why is Mars called the red planet? Who knows? Raise your hand electronically, please. If you know, wait, don't say it out loud, please, because I want people to have the opportunity. Ethan, go for it.
You should buy the Mars candy.
Because there's aluminum oxide and copper on it, which makes it red.
Right, and guys, what happens to aluminum oxide and copper? It
They
turns
rust.
into rust. So it's rusting, which is why we see this big rusty planet. We see this big rusty planet. Now, guys, I can't find it. I think I can still see it. Can you please roll that into a cylinder?
Uh-oh.
Yeah.
Use one finger.
You know, guys, I'm actually going to use the edge of my ruler to cut off 10%, because Mercury, which is 1/10 of the size of Mars, so put the bigger piece, the 9/10, that's Mercury, closest to the sun,
Well, Pluto.
and this remaining speck, which is 1/10 of 1/500th of 1%. It is 1/5000th of 1%, or 1/2 millionth of the mass of the solar system. And this is the planet that I am very emotional about. And the reason I'm emotional about this is because they demoted my friend Pluto a few years back. And then recently, about 5 to 10 years ago, they reconstituted it as a planet. David?
I just lost Pluto.
Oh, you lost Pluto. David, I give you permission to borrow 1/2 millionth from Jupiter. Okay, and I absolutely love that comment. Now, guys, I'm going to take Pluto and I'm going to put him on the little map thing. And I'm actually having trouble dropping Pluto. Like it's like sticking to my finger.
Missing Mercury and Venus.
Now, I don't know if yours looks anything like mine, but I chose not to include a particular mass in our solar system.
The sun.
Sun, because it's way too big.
Yeah.
Would you like to know how many pieces of Play-Doh you would need that are this size in order to, would you like to know how many?
Yes.
Like 1,000.
5,000.
Wait, who said like 1,000?
I did.
But I,
David. Sorry, David.
Ethan?
David.
David. So guess what, guys? You would need exactly 650 pounds of Play-Doh, which I don't know about you, but that's about 5 of me. So it would weigh about 5 people or 5 adults. I decided not to ask you to buy 650 Anna, I thought that would be too many apples for you to bring into your house. But guess what, guys?
It wouldn't fit on my desk.
Oh,
I made my own Play-Doh.
would you like to see a 75-centimeter diameter sphere, which is proportional to the rest of our solar system?
Sure.
No.
Yes.
I give you the exercise ball. This exercise ball was actually a little bit bigger, and I took some air out of it to make it exactly the right proportion. So I want to talk about this for a little bit, and it's a little awkward here because I'm holding Jupiter in front of it. Now Jupiter, okay, is 1/928 of the mass of the sun. What would happen if you put 928 Jupiters in the sun? Does anybody know?
Would it fill up?
Olivia?
It would explode.
Yeah, guys, first of all, it would vaporize. And second of all, you would be doubling the mass of the sun. So that's such a ridiculous question. I'm sorry, I digress. How many Plutos? By the way, here's Pluto. How many Plutos could I fit into the sun if I could do it? And the answer is, guys, and this is crazy, the answer is 1,300,000,000 times. Now, Earth, how many Earths? 1.3 million Earths. 1.3 million Earths can fit in the volume of the sun. Now, let me also tell you this, that we think of the sun as being absolutely massive, and we are absolutely tiny. But would you believe it, that the sun is actually called a dwarf sun, a dwarf star? It is considered one of the smaller stars in our solar system. I'm sorry, not our solar system, in our galaxy, in our Milky Way. And Alex, do you have something to add to that?
Universe.
Anyone? Okay, so guys, the sun is massive in comparison to our planets, but it is not massive in comparison to other stars.
Is it massive in comparison to you?
Oh, me? Well, right now, oh, look at that. Luca has a son. Oh, Luca, it's going to get hot, buddy. It's a little too hot for you to hold. Don't hold it too long. Okay. Now, I had to put it down because it was starting to burn my hands. I once flew to the sun, but my wings melted.
Ah, yes.
Who am I talking about? Which Greek mythology is that about? Icarus. That's right. Okay, guys. Now, I want you guys to please go to page 5. Go to page 5.
Oh, I forgot there were other pages on this.
Go to page 5, please. Now, I'm going to change my share with you. And wow, this has been a lot of fun. Okay, so what I did, guys, is I found and actually I found a website. I think it's called Initech or something like that. And I can make grids of any size. So the grid that I gave you is 200 millimeters horizontally by 270 millimeters vertically, which is 20 by 27 centimeters, and 27 times 2 is what, guys?
54.
48 or 54.
54. So therefore, there are 54,000 squares. Now I said, wait a minute. Maybe some people are going to be like Hannah and they won't have Play-Doh, so they could do it on a piece of paper. Well, guess what? I tried it and I failed miserably, but you can try it. You ready?
You can't make circles, can you?
So first of all I did was focus on percentages. So first I took 60%, which was easy, and that was Jupiter. I literally just took 60% of 270, and that was and I made a line, and I estimated. Then I took another 36%, or a little bit less than 36% for Saturn, and I tried to be accurate. I then took 2% and 2% for Uranus and Neptune, and guess what was left for all the other planets?
1 millimeter.
1/1000th of the mass of the solar system. That included Mercury, Venus, Earth, Mars, and Pluto, and Earth is half of that. So if you take out, guys, half of that, you are literally left with the other half to make up Mercury, Venus, Earth, Mercury, Venus, Mars, and Pluto. So it was kind of an epic failure, but it was a lot of fun trying. So
You
I
could just
hope you
make like
guys,
that grid times like 1,000, and then it would work.
okay, Seth, you're my kind of mathematician. Now, what I would need to do in that case is this.
Have a lot of paper.
I would need to blow it up 37 times. So this grid is 1/37th of what it needs to be. So Seth, if you could figure out a way to put 37 of these together, you could actually make a model of the solar system that would be somewhat accurate. Thank you, Seth. Alex, do you have a question or a comment?
It was like a fact. I'm pretty sure the largest star is UY Scuti. That's in the galaxy. I'm pretty sure it's 30 times more massive, but 1,700 times bigger in radius compared to the sun.
Wait a minute. So 30 times more massive, but the radius would be the cube root, Alex. The radius differential to the sun would be the cube root of the volume differential. So if the volume differential were, let's say, 64 times, that would mean that the radius would have to be 4 times bigger than the sun. Do you follow me?
Yeah, it says, I'm looking it up also right now. It says it's 17 times larger.
Yeah.
Only
Excellent.
30%
Excellent.
mass.
Awesome, man.
30 times mass.
Walker, what do you have for us?
Oh, nothing.
Oh, okay. I thought you were raising your hand.
Sorry.
So, guys, I want you to please go with me to page 4 in your packet. Go to page 4 in your packet right now, where we look at a couple of ratios that I put together. So I'm a little, for lack of a better word, ratio happy. So I said, let Earth be 1 and let the total mass of the solar system planets be 2,000. Remember, we are 1/2000th. So we are 1/2000th yet. And what is the percentage of 1/2000th? Does anybody know?
No.
Can you turn it into a percent? Think about it as a fraction over 100. Wouldn't it be 1/20th over 100, guys?
Oh, so 2000.
So
No,
yes, so it would be 0.5%. So the Earth is half of 1%. No, that's wrong. That's wrong. I scratched that. 1/20th. That would be 5%. 5% of 1%. 5% of 1%. Now, everybody, let's go to Saturn for a minute. Saturn is 718 2,000ths. Can you please give me the simplified fraction for that? Who can do that? Raise your hand electronically if you can give me that. And I'm trying to find, oh, there they are. And okay, Regan, go.
359 1,000ths.
That's absolutely brilliant. And why do I love that number over 1,000? Because who's going to tell me the percentage now? Adalia, go for it. So Adalia, what's the percentage?
My hand was just raised from before.
Okay. Anybody else? Go for it, Seth.
35.9%.
And that's exactly what we found for Saturn.
I have a question.
Yes, go for it.
How come planets are round and not like square or triangular?
Well, it's a great question. And I like to think about it.
Bubbles.
I like to think about it, guys, in this
Each
way.
planet has a gravitational pull that forces it together, an atmosphere.
Yeah, and guys, you can actually simulate what happens with gravity. When you roll a brick of snow down a hill, it goes from a brick and it'll turn into a sphere. If you were to roll sand that can hold together, it would become spherical. And it is all about gravity and the spinning nature. Okay, now, of course, these are not spheres. They are spherical. They are spherical. Now, I want you guys to come up with every fraction and every percentage if you can. And the next thing that I want you guys to do is use those fractions and percentages to look at the ratios. It's pretty cool, guys. Earth to Pluto. Just look at Earth to Pluto, guys. So Earth is 1,000 to 1. So Earth to Pluto would be 1,000 to 1 ratio. Earth to Pluto would be 1,000 to 1 ratio. And then you can do lots of these ratios and have a lot of fun with them. I gave you answers like Earth to Venus. Remember I told you it was a 10 to 9, that Venus was 90% of Earth's, okay? So really, really cool stuff. I hope that you enjoy the beauty of ratios, the beauty of astronomy, the beauty of microscopy. And the microscopy to me is looking at Pluto, which David, just so you know, I have lost my Pluto as well. This is Mercury now, which is 9 times bigger than Pluto. If you create it out of something really cool, please send it to me. Zarak? And you have to unmute yourself, buddy. So Zarak, you raised your hand. I'm trying to unmute you, but you'll have to help me out.
Yeah, no, it just accidentally raised.
Oh, okay. So guys, I hope you have a lot of fun, but I want to ask you one final question. And that is, which picture would you say is the best representation of the actual solar system? And I want you to focus on the sun. Which sun has a curvature which would make it the largest possible sun. So who's going to give me their ideas on this? David, can you give me your idea?
Would it be on the top row, the third one from the left? Yeah.
I really like that one, but I like one even more because this one doesn't have Pluto. Luca?
Or maybe the third row down, the first one. The first to the left.
That's pretty good. What about you, Zarak?
The one it's on the right in the second row.
Yeah.
All the way to
You
the
mean, yes. I really, really like that one, but the sun looks too small. Walker?
The top row, second one from the left.
Oh, you know what? I kind of like that one. That's got a very, very flat arc. Lila, what would you say?
I was gonna say the fourth row down, third.
There's noise in the background of somebody, so I can't. Lila, try again.
The fourth row down, the third one to the left.
This one here? And guess what, guys? That is my favorite. I kind of like the one that Walker chose, and also this one here, these two. But yes, this is my favorite one, okay? It really is. I even put the planet names there for you. I gave you some facts. And I also asked you, please do not buy 650 pounds of Play-Doh to make a relative model of the sun.
Challenge accepted.
Imagine it. Okay, guys, the sun is 0. Let's go from negative Play-Doh. Go. Negative Play-Doh, negative to negative Uranus, negative
Saturn, negative Jupiter, negative Mars,
negative Earth,
negative Venus,
negative Mercury, but don't ever say negative Sun.
sun.
negative Sun.
2, 4, 6, 8. Who do we appreciate? Mathletes, and you live right here. Mathletes. Guys, I will see you in 167 hours. I had a lot of fun inventing this particular lesson, and I hope that you make some amazing discoveries. Please send me pictures. I want, especially Hannah, with the apple before it rots.
Thank you.
You're welcome. You're welcome. You're welcome. Everybody say goodbye to their buddies.
Bye.
I will see you guys.
Mr. Kramer.
Bye.
Mr. Kramer.
Yes, buddy.
I'll do the put together 37 of those grids if you let me not do the rest of the homework.
You can do whatever you want, my friend. And you would print out, I think it's page 5, 37 times, but you're gonna have to put it in some sort of a rectangle array.
Yeah, but I could also do 40 and then figure it out that way too, right?
I think 40 would be close enough. I really do. All right, Cedric, Ethan, Hannah, Regan.
Bye.
Also,
Yes.
Also, guess the average weight of a cloud.
1 pound.
1 pound? Are you serious?
Oh, never mind.
Is it a pound?
A ton?
What is it, Seth?
1 million pounds. Because they're all made out of water.
You know, I have to tell you something. That makes me think of Jupiter, because Jupiter
Yeah,
is made of
that's
gas.
how I thought of it.
Oh my God, that's brilliant. That's brilliant. I'm actually going to do some research on that. Thank you for giving me that.
Mm-hmm.
Ethan and Seth, take care, guys.